The quantum revolution that will change everything. Every password you've ever created, every private message you've sent, every single financial transaction you've made, it all has an expiration date. And that date is coming a lot sooner than you think. There's a ticking clock on the digital world as we know it, and the sound is getting louder. A new kind of computer is on its way, one that threatens to crack open all of our digital secrets, from personal emails to national security data. But that very same technology also holds the key to creating a future that's truly unhackable. Section 1. The Digital House of Cards. So why is our digital world built on such shaky ground? Well, to understand that, you need to understand the lock that's supposed to protect it. Right now, almost all online security boils down to a simple mathematical trick. It's really easy to multiply two huge prime numbers together, but it's monstrously difficult to take that massive result and work backward to figure out the two original primes that made it. A normal computer, what we call a classical computer, would have to guess and check combinations for thousands, even millions of years to break just one encryption key. Our entire global economy, our privacy, everything is basically riding on the hope that nobody can do that math fast enough. But what if a new kind of computer didn't have to guess? What if it could just look at all the possible answers at once? This is where quantum computers come in. And no, this isn't just a faster version of your laptop. A classical computer stores information in bits, which are always either a 0 or a 1. Simple. A quantum computer uses qubits. And thanks to the wonderfully bizarre laws of quantum physics, a qubit can be a 0, a 1, or both at the exact same time. This is a mind-bending property called superposition. It lets a quantum computer run calculations that are just impossible for even the most powerful supercomputers on Earth. This threat isn't just theory anymore. Back in 1994, a mathematician named Peter Shor developed an algorithm that was basically a master key for today's encryption. We've known ever since that a powerful enough quantum computer could crack our security standards with terrifying speed. A problem that would take a classical supercomputer billions of years might be solved by a quantum one in a few hours, or even minutes. This is such a big deal that governments and companies are now racing to build post-quantum cryptography, brand new encryption methods designed to survive these attacks. The digital lock we've all been using for decades is about to get picked, and everything it protects is at risk. Section 2. The Unhackable Solution. But here's where the story gets really interesting. The same quantum physics that creates the ultimate code-breaking weapon also gives us the ultimate shield. The solution isn't a stronger password. It's a totally new way of communicating. It's called the quantum internet. Now, the quantum internet isn't meant to replace the one we use for scrolling social media or watching cat videos. Think of it as a specialized, ultra-secure network built for one revolutionary purpose: to send information with perfect security. It pulls this off using a principle that Albert Einstein famously called spooky action at a distance, quantum entanglement. Imagine you have two particles, two qubits, that are entangled. This means their fates are linked, no matter how far apart they are. Whether they're in the same lab or on opposite sides of the planet, they behave as a single system. If you measure one, you instantly know the state of the other. So here's the security trick. In the quantum world, the very act of looking at something changes it. If a hacker tries to intercept and measure a qubit being sent over the quantum internet, they can't help but disturb its state. That disturbance is like a broken seal on a letter. The moment it happens, the sender and the receiver know their communication has been compromised. The hacker can't listen in without leaving a trail. It's not just hard to hack, it's physically impossible to do it secretly. This method is called quantum key distribution, or QKD. It's the core technology that makes the quantum internet theoretically unhackable. Instead of trusting math problems to be hard, your security is guaranteed by the fundamental laws of physics. And this isn't just on a whiteboard somewhere. Pilot projects are already proving this works. China has already established a QKD network spanning thousands of kilometers, even incorporating satellites. And in Europe, the European Quantum Communication Infrastructure, EuroQCI, is building a similar network to connect government agencies and critical infrastructure across the EU. Section 3. A glimpse into the quantum future. An unhackable network is an amazing start, but it's just the beginning. The quantum revolution is set to reshape entire industries and change what we think is possible. Take healthcare. The quantum internet will allow for the perfectly secure transfer of patient data, locking down our privacy. It could even offer mathematical proof that a file has been permanently deleted, giving real power to the right to be forgotten. Looking further ahead, networks of quantum computers could work together to simulate how molecules interact, which could dramatically speed up the discovery of new drugs and lead to truly personalized medicine. In the financial world, quantum cryptography could secure every single transaction, verifying them in real time and making sophisticated digital fraud a relic of the past. The hyper-precise timing from quantum clocks could even create fairer markets by eliminating the tiny delays that high-frequency traders currently exploit. It could even strengthen our democracies. Imagine online voting systems that are immune to tampering, where every vote is sent and counted with provable security. Whistleblowers and journalists could use quantum channels to share sensitive information without any fear of being intercepted or identified. The technology could even verify your physical location for a secure service, without revealing your exact coordinates. This revolution also extends to science itself. By linking quantum computers together, we could create a distributed network powerful enough to tackle some of humanity's biggest challenges. From designing new materials and more efficient batteries to building far more accurate climate models. This isn't science fiction. It's the future that thousands of scientists and engineers are building as we speak. Section 4. The hurdles and the horizon. So when can you get your quantum internet connection? Well, the answer is complicated. We're still in the very early days. Building this stuff is incredibly difficult. Quantum states are ridiculously fragile, and keeping particles entangled over long distances is a massive technical challenge. For now, most quantum networks are still in labs and small-scale pilot projects, but the pace is picking up. Back in 2021, researchers at QTech in the Netherlands demonstrated the world's first multi-node quantum network, connecting 3 separate quantum processors. This was a huge step, proving the basic architecture can work. Since then, scientists have successfully sent entangled signals over dozens of kilometers of existing fiber optic cable, even having them share the line with regular internet traffic. This is exciting because it suggests we might not need to build a whole new physical internet from scratch, but can piggyback on the networks we already have. Tech giants like IBM, Google, and Microsoft are pouring billions into this, while new startups are popping up to solve specific problems. The general consensus is that the quantum internet won't replace our current one. Instead, it will run alongside it, as a super secure service for the most critical tasks. Most experts believe that within the next decade, we'll start seeing these quantum networks supplementing our classical internet, offering security and power we can barely fathom today. We are standing at a tipping point. The very foundation of our online world is about to be shattered, but a revolutionary solution, born from the strange and wonderful rules of quantum mechanics, is already on its way. This isn't just about faster computers or better passwords. It's about a fundamental change in how we communicate, solve problems, and build a digital society we can actually trust. The road ahead is long, but the first steps have been taken. The quantum revolution is coming, and it will, in ways we can and can't yet imagine, change absolutely everything. So what part of this quantum future are you most excited or maybe most worried about? Let me know down in the comments. And if you want to stay ahead of the curve on the technologies shaping our world, make sure to subscribe and hit that notification bell. Thanks for watching.